Hello and welcome everyone to our monthly WFO webinar. My name is Ilya Kranaухov and I'm the Development Manager at the World Forum Offshore Wind. And today's WFO webinar is on Offshore Wind Technology Updates. It's my great pleasure to welcome our three excellent speakers today. We have Roderick Ruinen, the Director of Mooreast. We have Stefan Backeljauw, the Business Development Director at Sarens, and Daniel Bossert, a Project Manager at TÜV NORD. And before we jump into the presentation, let me tell you a few things about WFO. The organization was founded in 2018, and we're a non-profit entity focused on offshore wind energy only, promoting offshore wind energy worldwide, and our members represent the complete supply chain, value chain. We have an international setup with offices in Hamburg and Singapore. In terms of WFO activities, it's very straightforward, and we focus on three things. We lobby for offshore wind around the world, we inform about offshore wind via all of our media channels, and we connect the global offshore wind community by doing events, in our days mainly online, but hopefully physical events will be possible again soon. And in terms of our members, we're very happy to have a broad range of global members from around the world, which you can see on this slide. We're delighted to have companies from all segments of the value chain, from North America, Europe, Asia, and even Australia. And if you are not a member of WFO yet, please make sure to join us and check out our WFO website, and also contact Gunnar Hersik, our Manager Director. If you have any questions regarding the membership, please do not hesitate to reach us. That's all from my side regarding WFO, and now I'm handing over to our first speaker for today, Stefan Backeljauw. We're going to have a Q&A session at the end of the webinar, so please feel free to submit your questions through the chat function on your control panel on the right-hand side if you have any questions for our speakers today. So without any further ado, Stefan, over to you.
Thank you very much, Elias, for the great introduction. Please, so welcome all. My name is Stefan Backeljauw. I'm the Business Development Director at Sarens. Of course, for those who doesn't know us, we are a family-owned company. We are based with headquarters in Belgium. We count more than 4,500 people worldwide. We are active in different sectors. And of course, since 2012, 2017, we are active in the offshore wind. So today, my presentation existed 37 pictures that I wanted to show with you. And of course, this also would reflect more or less our equipment that we have available. And I would say at Sarens, we have a huge amount of different type of equipment available. And together with this equipment, and of course, together with our expertise, we are offering a lot of different logistic solutions. So today, actually, I wanted to share more or less the idea, and actually also our credo is that, of course, everybody can really rent out cranes and equipment, but at Sarens, we really commit from fabrication to foundation. And that's where, of course, the logistic part and, of course, also the liability is coming in. Where we really, as a company, are managing complex projects, and as you could see here, are really combining different types of equipment. So we always find a solution at Sarens, and that could be, of course, a combination of jackets handling, TP handling, barge, complex barge handling, or even TP handlers. So that's something that we also built for one of our customers. It's an innovative solution built by Karl Sarens to transport the TP handlers. So this is the first version where we are showing the complexity of managing this logistics onshore on the marshalling yards. Here, this really reflects a complete. Here you see the TP handler, you see the sand dunes. You see our CC 68s and 88s operating on together with our barges. So here you can see what we are really want to mean with offering the solution from fabrication to foundation, because here we really show that we combine different, I would say different solutions, and of course that we are doing this complex liftings. This is also just to show you that in total with 4 different cranes we can do a complete lifting project or operation. And I think that's really where Sarens is making the difference today, and where you also can see like the grillage on the barges together with our SC Sarens giant crane. We're offering a total solution. So this one of the big advantages of the large cranes is of course that regarding the ground pressures and the bearing capacity that we can optimize due to our technical ringer crane. So this is really something that that it's also beneficial, especially for older case where we are always looking to the best solution. So here you can see our SGC 120 operating, and of course together with the barges and smaller equipment. I think this was one of the first projects with DEME. DEME is one of the Belgian marine contractors together with Jan de Nul, of course. They're also since the beginning, we are very active together with them on installing turbines on the wind parks. Here you can see also another beautiful picture of that operations on the onshore activities of an CC88. And of course, also these days we receive a lot of inquiries from shallow waters operations, where of course Sarens, we are mainly focusing on onshore logistics, so meaning everything in relation to port marshalling activities, but even also on shallow water applications, we are getting required or requiring our expertise or sharing our expertise as we already did on other projects. This just to show you that this is a roll-off operation. This is in China. So as an international company, we are following our clients, and I think it's clear that offshore wind is not only Europe. It's clear that we are looking to Asia, the US today, in order to follow our clients and support them with the right logistics. That's really our goal. And of course, it's clear that everything is getting bigger and bigger, heavier and heavier. So on that side, we don't have any limitations. So we follow also on that side, we optimize our equipment. We combine different technologies, and we combine, of course, this combination of techniques and equipment in order to find the best solution for our clients. I think it's clear that here the jackets on the SPMT handling. This picture shows really also there was a huge challenge in this application where the ground bearings of the quay were actually not allowed to do the complete transport. So here we lifted up the spans in order to make sure that it didn't touch the quay, we didn't touch the ground up to the barge, and that really also shows to which inventive solutions we are able to come together with our clients, of course. So this shows then the same picture. And here again, in different combinations, different like the grillage on the pontons, in order to give the full service. And I think it's clear that products are getting fabricated in one part of the world, getting transported to another part of the world, to the marshalling activities where everything happens. Also here with Sarens, we have a large extensive experience in operating worldwide and mobilizing and demobilizing our equipment all over the world. So there are no limitations on that side. But it's always impressive if you see how big this kind of equipment, of course, is, and what kind of equipment we are handling. It's a matter of managing liability, and I think that's really also important to mention that managing liability and of course providing the best solution is really our key challenge. And of course to be on time and to make sure that everything is happening safe and well organized. Here you can see the saddles on the SPMTs. That sometimes if you have a different diameter of different lengths to transport, we can easily modify the diameter of the saddles. That's something if you're in a complex environment, that's really something beneficial, of course. And again, if you have any inquiry or any specific question, please send us or ask us for more details. We are more than happy to support you with our project team based in Belgium, but of course we are all spread all over the world. We are really inviting you for contacting us and make sure you if you have any questions, I'm looking already forward to answer them, of course, through Ilias, through the organization. Thank you very much. This was my 37 slides, and I hope it was a bit of interest for you. Thank you very much, Ilias.
Oh, excellent. Thank you very much, Stefan, for this very interesting and nice slide visual overview of innovative solutions for floating offshore wind especially. Yeah, that's very nice. Thank you very much. And now it's my great pleasure to introduce our next speaker, Daniel Bossert. Daniel, over to you.
Yeah. Yeah, thank you, Ilya. So, yeah, first of all, I want to thank you that we got the opportunity to share our experiences with remote inspections we made through the last months. A service which is already under development at TÜV NORD since years, but which moved to the focus beginning of last year due to the Corona pandemic. And the pandemic caused travel restrictions we all experienced. But let me start with some words on me and on TÜV NORD. After some first years in naval architecture, I started my career in offshore oil and gas 16 years ago. 5 years later, I was involved in the first offshore wind projects as a project manager and project engineer. Then 9 years ago, I joined a certification body. And since then, I was involved in the certification of a number of wind farms in the German Bight, UK, and the Netherlands. Either as a project manager or as an expert for certification of transport and installation. And I enjoyed to see the Rea Mate offshore substation in Stefan's presentation again, which was also certified under my responsibility. And then in 2018, I joined TÜV NORD, where I'm currently responsible for the certification of the Hollandse Kust Zuid offshore wind farms. Within the TÜV NORD group, we have about 150 entities in Germany and abroad, with a record of worldwide projects, let's say from Iceland to Fireland. So you see the red triangles which show projects we did throughout the world. With the renewable sector of the TÜV NORD group, we generated a revenue of about 42 million euros in 2020 with the sectors certification, wind site assessment and inspection, environmental services, and solar. The number of employees today, which is more than 350 compared to the figure of 2018, which was about 200, gives a good impression of the segment's growth of the past years. We have the cluster wind certification, site assessment and inspection, provide all services related to testing, inspection and certification for the wind energy industry. which includes all kinds of inspections during manufacturing, installation, commissioning, and operation, wind resource assessments, environmental impact studies, technical due diligences, lifetime extension calculations and inspections, and of course, certification of turbine types and projects. Yeah, here's a slide showing our current lighthouse or flagship projects. We are involved in we are certifying the next generation of Siemens Gamesa offshore wind turbine. As I said, we are certifying the Hollandse Kust Zuid wind farm zone, which is one of the biggest wind farm zones under construction and also plan to operate subsidiary-free. And the wind farms Gode Wind 3 and Borkum Riffgrund, where we are involved as project certifier for the substation and the inter-array cable packages. Now let's come to the remote inspections, which is the core theme of this presentation. The basic idea of remote inspections is quite simple. The specialist inspector receives live pictures on his office screen taken by any kind of mobile device by a transmitter who is located on site. The development of these services started already several years ago, mainly driven by our colleagues from the mobility business. But since 2018, we were also testing these options for inspection services in the wind power industry, both at manufacturer sites, onshore, but also in operating offshore wind farms. We distinguish here between three major types of remote inspections, as shown on the left side of the slide. The first option, the remote expert option, is more or less a normal physical inspection with the add-on that the inspector on site has the possibility to call in specialists from the back office who may take responsibility for single aspects of the inspection. Typical case for the partly remote option here in the middle of the slide is a first factory inspection or capability audit, like the ones required prior to the manufacturing surveillance in the course of a project certification. In such a case, the quality management and manufacturing processes part may be done remotely by an auditor from the TÜV NORD office, while the shop tour part may be conducted by a local TÜV NORD inspector independently. Then the last option would be the fully remote inspection, either with a local TÜV NORD employee as transmitter or a client or manufacturer's employee acting as transmitter on site. With the travel restrictions caused by the corona pandemic starting from March 2020, the further development of remote inspection gained really speed at TÜV NORD, so that we have now a track record of about 60 remote inspections since June last year, only in the wind industry. That enables us to proceed with our clients' projects without compromising the agreed timelines. There are, of course, some problems which we identified in the course of the development and also lessons learned from the inspections to date. An aspect which fortunately was already addressed quite early by our colleagues from TÜV NORD Mobility is data security. They developed a dedicated app called Live Expert, which complies with the General Data Protection Regulation of the EU. Then, as a second example for problems we faced, we developed, that we experienced that the permanent movements of the camera device caused symptoms which are similar to seasickness at the receiving inspector in the office. So he required more or longer breaks compared to physical inspection, which compromises efficiency, of course. This may be improved by the use of or this can be improved by the use of the gimbal device, as shown here on the lower left side on the slide. But still, there are additional limitations with regards to the video picture, as the field of view, which can be recorded by standard mobile devices like a mobile phone or on tablet, is reduced. This can also be reduced by the use of a better camera technology, like, for example, an action cam, but still there's room for further improvement. Then at the last example, one can imagine that the communication between the transmitter and the receiver is of very high importance for the efficiency of such a remote inspection. So we recommend the use of headsets with noise cancelling options wherever this is possible and wherever this does not compromise the safety of the transmitter. To conclude, I can say there are already existing technical solutions, and we have reached a quality and efficiency level so that we consider the remote option as equivalent for, as already mentioned, capability audits, first factory inspections, as well as for follow-up inspections. The same applies for partly remote inspections, with a transmitter having basic knowledge of the inspection or the inspection scope. For fully remote inspections for the time to date, we allow those for up to 50% of the total number of inspections planned for an individual project at an individual manufacturing site. This figure may increase further with further technical improvement of the equipment, the bandwidths, and of course the software applications. I personally expect that this remote approach will remain more and more attractive even post-corona, since it brings along many benefits on an economic side and other sustainability aspects. That brings me to the end of the presentation. Thank you very much for your attention. And I hand over back to Ilya.
Okay, great. Thank you very much, Daniel, for this very insightful presentation. And now it's my pleasure to introduce our third speaker for today, Roderick Ruinen. Roderick, over to you.
Let me unmute, that helps. Can you see the presentation?
Yes.
Okay, good. My name is Roderick Ruinen. I'm a director of Mooreast Europe, located in Rotterdam, and also the technical director for Mooreast Asia, located in Singapore. I'll give a brief introduction of our company, and then I will focus on using drag embedment anchors for floating wind turbines. Mooreast has two offices. We have our main office located in Singapore. Here we have a fabrication yard where we fabricate steel products, drag anchors, but chain stoppers, buoys. We have our engineering and sales departments there. In Europe, in Rotterdam, we have a small business development sales office, and if needed, we can also do fabrication in Europe, whereby we subcontract to fabricators with whom we have a long-standing relationship. And we also have representatives in a number of locations worldwide: USA, Brazil, Malaysia, to name a few. These basically act as sales offices and then report back to either Europe or the Asia office. We typically can supply full mooring systems, basically starting at the winch all the way down to the anchors. Some of these products we fabricate ourselves, and some we buy from dedicated suppliers because they have the equipment and the experience for that. Examples of these are shackles, synthetic ropes, chain. But anything that consists of fabricated steel, generally we can fabricate in-house. We have built drag embedment anchors, buoys, chain stoppers, and generally anything that is required. In Singapore, we typically have a large stock of steel plates, which allows us to start fabrication quickly But because we have the stock, we also can offer our products at competitive rates because we buy in bulk, and the whole fabrication process from steel cutting to final delivery is in-house. We also have our engineering team located both in Singapore and in Rotterdam. We do geotechnical analysis of drag embedment anchors, but also for other foundation types. Structural analysis is performed on all our products leaving our factory, and according to applicable class rules. We can also perform mooring analysis, which then basically allows us to design a complete mooring system for the client according to what is required. So now we go into the subject matter, the drag embedment anchors. We basically have three types of drag embedment anchors. What we call the MA5P, which is a general purpose anchor, suitable for a wide range of soil conditions, running from sand to very soft clays, and it has been applied for both temporary and permanent mooring systems. We have a specialized version which we call the MA5S, which is a modified version of the MA5P. It is smaller for the same weight, and we've designed it to be suitable for very hard soil conditions, cemented soils, but also there are some areas in the North Sea which consist of extremely hard clay and also require specialized anchors to be used. Our third anchor is the MA7P. This is an anchor that's been designed further. We've optimized the size and the weight, and this gives us a higher holding capacity to anchor weight ratio. Looking at the use of our drag embedment anchors, they've been used worldwide. Basically any area that up to now has been of interest for oil and gas activities has also seen the use of drag embedment anchors. And now also more recent with the floating wind turbines and other renewable energy floaters. Drag anchors are being used everywhere. They've been used in wide ranges of soil conditions, very soft clays, which you generally find in very deep waters, but in some places also in river delta areas where the soil has been deposited, all the way up to hard clays, which we see a lot in the, let's say, North Sea area. Also, if you go to the east coast, for example, of Canada, sands are very common, but also cemented soils and carbonate soils, which are then typical of, let's say, the Western Australia coast or some areas in the Persian Gulf. And we see a wide range of applications. They've been used a lot for permanent oil and gas facilities with design lives up to 25 or 30 years, depending on the project requirements. They've been used on mobile offshore drilling units, where they are very successful. And the interesting thing here is that they get deployed and recovered on a regular basis, because the drilling vessel moves a lot. Floating offshore wind turbines, we've seen a lot of, we're seeing drag embedment anchors being used, but also for floating PV and floating tidal. The application of drag embedment anchors is also of interest. So now looking specifically at floating offshore wind turbines, I'm going to pose the challenge that, let's say, the soil type or the location is not the challenge when selecting drag embedment anchors, because there's a long history in a wide range of soils for drag embedment anchors to be used. But the challenge is more in the fabrication of the product for a commercial wind farm. This is not specific for just a drag embedment anchor, but also applies to the complete mooring system. To put that in some perspective, a typical oil and gas floating facility will have anywhere between 6 to 12 anchors. There are larger numbers that have been used, but this is a typical range. If we look at the demonstration projects for floating wind turbines, which have basically been single units, you're looking at 3 to 9 anchors being used. So this is in line with a floating oil and gas facility. But if I now look at a complete wind farm, and I've used 50 units of floating turbine as an example, the number of anchors that are required goes up to anywhere between 150 to 450. So we see a huge increase in anchors being needed. So with the fabrication, this leads to the following, let's say, smaller problems. You need a large amount of cut steel plate. You need a large amount of round bars. The connectors connecting the anchors to the mooring lines. There's many welders required to fabricate the anchor. You get a large number of inspection points, which by not only internal QA personnel, but also by classification society. And you would also need large storage facilities, because the anchors will get quite big. And there's a lot of anchors there. So this needs to be looked at quite carefully to ensure that the product can be supplied for the project. But of course, there are solutions that can be developed. For example, delivery of the product in batches. So instead of supplying a large number of anchors, coordinate delivery with planned installation of the equipment, so that the use of storage facilities is limited. Start discussions with our subcontractors at a very early stage to ensure that the products can be supplied on time. Depending on what is needed, this can be long delivery times, but some products can also be quicker. Consider using multiple subcontractors. For example, here in Rotterdam, we already use a number of subcontractors for fabrication, but also for steel plates. And this can be extended to other locations, depending on, for example, where the project is. For example, if there's was to be a large project in the USA, we can consider doing local fabrication there with multiple yards fabricating the anchors. So these are all possibilities. And a final option that I would like to mention is, let's say, standardization on the anchors themselves. Normally, we can supply a wide range of anchors, anywhere from 500 kilograms up to 40 tons, which we recently fabricated. But focusing on maybe 3 or 4 different anchor sizes, which can be used on multiple projects, gives advantages. For example, all the engineering can be done ahead of time. It can also be passed along to the classification societies ahead of time. It is possible to use stock materials. Looking at the fabrication process from our Singapore office, we could invest in larger stocks of steel plates, which would then allow the anchors to be fabricated much quicker. Or you could even take it one step further and look at fabrication of anchors for stock, so that you already have a large number of anchors ready for use when a project comes along. So basically, just I've wanted to show you the drag embeddment anchors. That yes, they can be used on floating wind turbines, and yes, there will be challenges when we use them, but these challenges can definitely be overcome, so that the product can be supplied on time and for the project. And with that, I come to the end of my presentation. I would like to give the control back to Ilya.
Okay, great. Thank you very much, Roderick, for this very nice presentation of our anchors. And now we have approximately 20 minutes or so for the Q&A session. And we received a few questions so far. So maybe the first question will be to all presenters. And by the way, unfortunately, Stefan had to leave. So now I have only 2 speakers online to answer the questions. And the first question would be, what are the current technological challenges for offshore wind? So maybe Daniel first, and then Roderick.
Yeah, of course, the development goes in the direction of floating wind, but the challenges here I would leave to Roderick, as this is more in his point of view. For fixed wind, the challenge is the growth of turbine sizes. So with always bigger and bigger turbine sizes, rotor diameters, the foundations have to compete and to grow as well. And then there are the limits for piling equipment, handling of such big and huge monopiles or jacket structures.
Okay, great.
Okay, for my point of view, I see the challenges, let's say, in the logistics, but this is of course very broad, because it starts with the logistics of the raw materials, which then have to be converted to products like the anchors, and then you have the logistics going to the actual installation offshore, with let's say small wind farms. Let's say maybe taking High Wind Scotland or Kincardine as an example. There you're still working on, let's say, what's similar to offshore oil and gas experience. But if you look at going let's say, steps further, then let's say the installation of offshore also becomes a challenge, because the volume of the equipment that needs to be installed increases dramatically.
Okay, great, thank you. So the next question would be also similar on challenges. What are the most common technological difficulties in the new markets to overcome in order for offshore technologies to blossom in those markets? And then maybe we can go Roderick first, and then Daniel.
Okay. Looking at floating wind challenges, I think there's a lot of experience, let's say, available from the oil and gas for the past 30 or 40 years, and that this experience will make the wind projects probably less challenging, because let's say a lot of things have already been done. Challenge maybe in some of the materials that are used, and possibly let's say the electrical cables installation and life can be a challenge. But I think a lot of things can be engineered, as long as you start looking at it long before you actually need it or need to do something.
Okay.
Yeah, maybe I would like to add that with the new markets, the volume, of course, increases, and that goes in the direction already mentioned by Roderick. The logistic and the availability of materials is a challenge, but also the availability of skilled engineers and resources there on that side should not be neglected.
Okay, great, thank you very much. So the next question would be, what's the role of standardization in the technological improvement in the offshore wind, and especially floating? So what's your input on that? And maybe we start with Daniel and then Roderick.
So I didn't get the first part of the question. The room for?
Yeah. What is the role of standardization in the technological improvement in the offshore wind and especially floating?
I think offshore wind is a big chance to have a standardized project, and I love to see in the presentation the approach with standardized anchor sizes. The same can apply, of course, for the floaters and all what is above. Yeah, we are getting more independent from local environmental aspects with the floating option, I would expect. So standardization would be possible more and more.
Okay, thank you. Roderick?
Yeah, I think the standardization will make it, let's say, the whole process move faster, because let's say the amount of equipment will be the same, but let's say it's easier on the purchasing and fabrication side to plan ahead. But even for new projects, upcoming projects, you could also start planning ahead. But if you know, let's say there's a large project coming up in 3 years, and you know that you can use standardized equipment, you can already start your sourcing process, so that let's say you can meet the deadlines that the project requires. And of course, the standardization reduces the chance of errors occurring through the supply chain.
Okay, thank you very much. The next question would be, what are the offshore wind technologies of the future, in your opinion and based on your? So maybe we can start with Roderick and then Daniel.
That's an interesting question. Looking at wind, well, actually, see, I'm not looking at wind. I think the technology direction will probably be, let's say, multifunctional use of the platform. You're already seeing, let's say, ideas of, let's say, floating wind with. I've seen seaweed farms that could be introduced, but I've also recently seen an idea of combining it with fish farm. You could also start adding in solar or even tidal turbines if needed. But basically having a single unit that has multiple purposes.
Okay, great, thank you. Daniel?
Yeah, we see in the near future already developments like floating wind. It has been mentioned several times already, but also we can imagine how far out to the open sea we go, the more interesting will be power to gas solutions come, or storage ideas will come up in the near future, I'm pretty sure. So I think those sorts of multiple uses will come. I do not expect so much more growth or total different turbines in the near future. I think won't be the application, the additional purposes.
Okay, great, thank you very much. The next question is, which role do you think machine learning could play in the advancement of offshore wind? So maybe we can start with Daniel first and then Roderick.
It was machine welding?
Machine learning, yes, and especially in your respective fields of work, yes.
To my knowledge, machine welding is quite common for production in the offshore wind industry, especially when we look at the big towers and monopile foundations. We have a quite automated welding approaches already.
Okay, so perfect. Thank you, Roderick.
Can you just clarify? Did you say machine learning?
Machine learning, yes.
Learning. Oh, sorry.
Oh.
I understood machine welding.
Yeah.
Yeah, sorry, machine learning, yeah.
It's an interesting one. I don't have an answer for that one at the moment.
Okay, no problem. And then the following question would be, how easy is to recycle elements of the floating offshore wind turbines? So do you have any experience with that?
Yes, I think let's say elements can be recycled or can be reused, but this also depends on the design of the product. Let's say if a project is designed for 10 years use and the material is optimized, then there's a high chance that you could get fatigue issues if you take it to another project after that. So you can reuse the equipment, but you will need to do additional checks on the products or the total floater to see if it is still suitable.
Okay, thank you. Daniel?
I guess it's like for other machinery comparable like for other machinery onshore. It's a matter of the business case or the economics behind it. If it's worth to reuse, to refurbish some components. From an environmental aspect, the recycling is, I believe, also comparable to machinery from other industries, except the rotor blades, where still big questions are. But as far as I know, those are addressed in several research projects already.
Okay, great. Thank you very much. So I think all questions have been answered. So thank you very much for sharing your views today. That's already bring us to the end of the webinar. Thanks, Daniel, Roderick, and Stefan for your time, and thanks everyone for attending the session. Please join us again the next months. The following webinar will be on May 19th, the same time, 1 to 2 p.m. Central European time, and the topic of the webinar is Offshore Wind Market Updates. So thanks everyone, and have a great day. Bye-bye.
Thank you. Bye.
Thank you. Bye.